Hello and welcome to Algebra 1 lesson 91. Today we've got a couple of exciting things to study and I'm going to throw away this marker. Ooh, made it in. Alright, so first of all, we're going to deal with inequalities where we have a little bit more work to do. So there's two fundamental rules that you have to know. First of all, we are allowed to add the same amount to both sides. And we are allowed to leave some room there. Multiply by the same number as long as it's positive. If it's negative, we have to switch the sign of the inequality. So let's try this one first. We have 4 minus x is less than or equal to 6. Okay, so here I can add the same amount to both sides. And since I don't want to multiply by both sides, I can simply add x to both sides and remove the 6. Right? Because I can add the same amount. And it's okay to add a negative number. It's only multiplying where we have issues. So one way to solve this would be to add x to both sides and subtract 6. What do I get? Lining up my inequality sign, just like we always will. 6 minus 6 is 0. And I have x on the right side. Now I have negative x plus x, which is 0. And I have 4 minus 6, which is negative 2. So negative 2 is less than or equal to x. Now from there, of course, I can graph. Put the number that you're concerned about in the middle. And give me at least 2 numbers on either side. If x is greater than or equal to negative 2, then I should fill in the circle, go up, and then draw an arrow to the right. Okay? The danger with doing it on the number line like the book does, instead of going up a little bit, is that you might feel like it only goes to 0 if you only draw the line that far. So I like to draw it above so that it goes past. Now, the other rule is that you're allowed to multiply by the same number on both sides. This is not given in any of our examples. So let's talk about the opposite of this rule. What if we have a negative and we want to multiply, like in our previous example? This would obviously be easier if I just multiplied by negative 1 on both sides. So if you have a negative, you have to change the sign or the direction of the sign. You never change whether it's equal to or not. So if it's equal to, it's still equal to. If it's not equal to, it's not equal to. But you will change the direction of the sign if negative. So let's go back to that same example. That would be example 2 from this lesson. We have 4 minus x is less than or equal to 6. Now I'm going to subtract 4 from both sides, which makes a little bit more sense to me, because I always like to have x on one side and everything else on the other side. So that gives me negative x is less than or equal to 2. But you'll notice that our solution was x is greater than or equal to negative 2. That's because we dealt with the minus sign. So I'm going to multiply both sides by a negative. But I must change my sign when you do that. So I get that x is greater than or equal to negative 2. Just like I did up here. Then you would graph as always. Let's try another one. So we have negative 3x plus 4 is less than or equal to 13. First step, I'm going to add and subtract. Okay, just like we would in solving an equation, you want to kind of go backwards on the order of operations. You want to get rid of your adding and subtracting first, then deal with multiplying and dividing. So I can subtract 4 from both sides. That gives me negative 3x is less than or equal to 9. Then I'm going to divide by negative 3, or multiply by negative 1/3. It's the same thing. But since I divided by a negative, I have to change my sign. So what is that going to give me? Negative 3 divided by negative 3 cancels. 9 divided by negative 3 is negative 3. So that tells me x is greater than negative 3. How do I graph that? Well, 3 goes in the middle. I'm going to give at least 2 numbers on either side. A positive 2 and 1. Then, since it's not equal to, I will leave an open circle at 3 and draw the arrow to the right because x is greater than negative 3. All right, now let's move on to the next section of this lesson. We're going to learn 2 more formulas that you have to know, and that is the volume and surface area of a sphere. So write this down in your notes. It will appear on Thursday's equation quiz. So the volume of a sphere is 4/3 pi r cubed. You know its volume if you have a cubed, because a cube takes up volume. If you only square this, which is what a lot of students make, it's a mistake. A mistake a lot of students make. That was cool. Then you're only giving me an area, not a volume. Now, this is why it's confusing, because the surface area of a sphere, remember that a sphere is like a ball, okay? Completely round on all sides. Or a marble. That is 4 pi r squared. So these are very easy to mix up. And so that's why I'm encouraging you. Make sure that you get them separate. The surface area, or the area on the outside of it, is 4 pi r squared. We know its area because it's r squared, right? Square things, a square has area. A cube has volume. Now, how would I use these? Well, let's say we have a sphere. I'll draw you a terrible looking sphere for, there we go. And it has a radius of 3. How would I find the volume? Well, I'm going to plug in 3 for r. So write the equation first. That's your first step, always. Then 4/3 pi times 3 cubed. Can you cancel one of these 3's? Yeah, but not all of them. So I'm just going to multiply it out as is. Pi times 27. 27 and 3 cancel, make 9. 9 times 4 is 36. And my units are in centimeters cubed. Because again, a cube takes up volume, so our answer should be cubed. Now let's find the surface area. But this time, let's make it a sphere of radius 4. I'll turn back over here. So if I have a sphere of radius 4, then my surface area is still, because this is my formula, 4 pi r squared. And please, don't take a month to memorize this formula. Just memorize it now so you can get it. Thank you. We're going to plug in r. R is 4, so r squared is 16. 4 times 16 is 64. Now, since this is area, I expect my units to be squared, because a square has area and a cube has volume. And that is problem set 91.